Okay, I want to do a little review of angular momentum. So first let me remind you of the experiment that we did in the lab. You took a disc. It was a plastic dinner plate that we used in the lab. And it was rotating. And then what we did was we took another plate, another disc, it was the same size and shape, which was not rotating but was sitting still. And we dropped this one down onto the other one. After the top one dropped onto the bottom one, the two were sandwiched together, one sitting on top of the other, and they both rotated. But they rotated more slowly than they did than the fast one, the bottom plate was at the beginning. Now, so you could say that the bottom plate rotated more slowly than before, and the top plate now was rotating faster than it had been before, because here it had been rotating not at all. Now, we have quantities that we can assign to how fast these things are rotating. And the quantity that we use is omega. So omega is called the angular speed and you calculated the angular speed for these different disks in different situations, and you may remember that that was done by multiplying 2 pi times something called the frequency. You may also remember that we found the frequency of the rotation by the following. The frequency of the rotation was the number of rotations divided by the time. You measure the time, you just counted the rotations in the lab and you measured the time with a stopwatch. So now now let's look at this situation here. Well, first let me just emphasize this omega here. This omega is just a way of saying how fast is it rotating. Okay? So omega just tells us how fast it is rotating. Now for this object here, omega was equal to 0. Let's take an example of an object here where omega, let's calculate omega for this object. So let's suppose that it went through 10 rotations in 5 seconds. Then the frequency would be 10 over 5. And then we could calculate omega for that thing. So omega then would be 2 pi times 10 over 5. That's equal to 2. So that would be 2 pi times 2. So in this example, omega would be equal to 4 times pi, which is about 12.5. And the units would be 12.5 per second. Okay, so the frequency was 10 over 5 seconds, so we should have units there, and then omega will be 2 pi times 2 per second, and then we'll have 12.5 per second. That'll be the omega for that spinning plate there. Now, you may recall that in the lab we observed these plates afterwards spinning more slowly than they were at the beginning. So let me write these numbers down here. Leave the plates there. Now, suppose this one here had omega of 12.5 per second. And most of you found in the lab that when you had the two plates spinning together after you dropped the top plate onto the bottom one, that omega was about half what it was here. So let's just suppose, for example, that omega was equal to 6 per second afterwards, after the top one had dropped onto the bottom one. Well, in physics we like to say that there is something in this plate which gets transferred to that plate. So this plate slows down and that plate speeds up. And after the two plates are spinning together, they're sharing equally some kind of rotational stuff which was in this plate. And that stuff we call angular momentum. So you can imagine, think about angular momentum as some kind of a stuff which actually is inside this plate, and there's none of that stuff in that plate. And after the top plate drops onto the bottom one, you could say that those two plates are sharing the same amount of stuff that was all in the bottom plate at the beginning. The more of this stuff, which we call angular momentum, the more the angular momentum there is in a plate, the faster it'll spin. So you could say that the angular momentum went from the bottom plate to the top plate. And that is actually there's a general statement we can make about this, which is really always true in nature. And that is that angular momentum, which we call L, tends to go from fast spinning objects to slow spinning objects. So here we have a fast spinning object, and here we have a slow spinning object. And the angular momentum goes from the fast spinning object to the slow spinning one. Afterwards, they're sharing their angular momentum together, and they're rotating together at the same speed.